All right. Great to see so many faces here. I'm Dennis. I work at Qt, and I'm one of the people behind the development of Qt GRPC and QtProtobuf. And to get started, can I see some hands? How many of you have heard about Protobuf or gRPC before this talk? Oof. Okay, like 70% maybe. And how many of you have used it, have actually written code in it? Okay, that's not that much. 10%, 20 maybe. So I will not only talk about performance, I will also explain the basics of them a little bit. So Protobuf describes itself as Google's language-neutral, platform-neutral, extensible mechanism for serializing structured data, whereas gRPC says it's a modern, open-source, high-performance remote procedural call framework that can run anywhere. Okay, sounds great. So let's explore Protobuf a bit more. I would divide it into 3 categories. So we have the language, the compiler, and library functionality. So the language, protocol buffers, and in a .proto extension. And you can see here how we define a message called event, and it has 2 fields. It takes enum type and a string name. And then we have the compiler. Compiler, actually, weird name. It doesn't compile to binary, it transpiled. But Google picked Proto C, so it's the Protobuf compiler. And it can read those protocol buffers and output other programming languages that you can then use in your code. For instance, here we use it in C++, so we include our generated file here, and then we can declare two types here, give it a type and a name, and then we print the serialized output once as JSON and once as the Protobuf format. And if we would do this, we would, of course, invoke prodoc and compile it, link it, run it, and see, well, we are much smaller here than JSON. Of course, JSON is very verbose. And we achieved that because we have binary keys, for instance. So our type here just takes up 1 byte. And it's of type var int with the value 2, which is system. And then followed by the field 2 is of the name field is of type length, followed by 9 bytes, and then the string, and that's how we end up with our 13 bytes. Okay, let's look at some benchmarks. In the end, we're talking about performance here. So we compare here protocol buffers with RapidJSON and PuckIXML, 2 very well-known and fast libraries. And we can see that we are, for the deserialization step, roughly 2 times faster than RapidJSON and actually slower than PuckIXML in this specific benchmark. And for serializing, we are 3.5 times faster than RapidJSON and 1.5 times faster than PuckIXML. But where Protobuf really shines is in the wire format size. So if we look then at the output of the serialization, we see Protobuf is 6.5 times smaller than RapidJSON and roughly 5 times smaller than PuckIXML. And now we could say, well, I mean, it's a very verbose format. We could compress it, and we did. And we could also compress the protocol buffer format, but we don't get such a nice reduction there. So we are just 2 times smaller in this case, but also like decompressing its overhead that is not included in the processing benchmark. So Protobuf in general provides us the schema-driven API. It's language independent. It's actually a IDL, interface definition language. So we describe how our data should look like with strong types. So it's directly clear what they should contain. And it also provides safe evolution. So if you're careful, you can have backwards and forwards compatible interfaces and safely evolve over time. Then the code generation provides optimization for each target language, meaning we can use specific features of the Python language or the Ruby language. And then when it comes to the binary, when we serialize it, we are all the same. It's all equal. And harness the features of each language. And Prodoc has a quite extensible plugin ecosystem. There's a huge open source community around that, and there are many plugins for it. And of course, performance, it's fast and it's compact. But on the downside, it has always the dependency on the schema definition. So without the schema, we cannot do much with a raw binary. And since we also have the Protobuf compiler step in between, it adds some complexity. So it's not as a JSON API where you just can read everything and use it and understand it. You would always have to look it up on the schema. So let's introduce QtProtobuf. And I would say it's a strong handshake that we have here. We are not competing with them. We're joining the ecosystem. So we can also communicate with all those other great languages out there. So we can also take all the good points of Protobuf, and then what QtProtobuf adds is the messages are native Qt C++ types, meaning they're meta-object system compatible, they're easy to use in models, views, or signals, and the API, the generated API, uses already familiar Qt types that you know, like QString, QByteArray, QList, and it's also therefore very easily integrated into the rest of Qt's ecosystem. You can also use Protobuf messages from within QML, and you don't have to invoke Prodoc manually, as I've shown here before. We have a very nice CMake API where you can, with a two-liner, do all of the steps I've shown before that we did manually. So here on the left slide, you see the Protobuf code from the beginning, and on the right, the QtProtobuf equivalent. So you see, first of all, our headers are QPB prefixed. Then by default, we use camel case for the generated API. Our enums are scoped, and the bigger difference is we have separate serializers. So if you look to the left, for instance, in Protobuf, if you want to serialize in JSON, it's hidden in the util namespace, and in QtProtobuf, you could also define your own serializer. We have an abstract interface for that, and then just plug it into the serialize function, and it would work. So this is, if we would now also compile it, we use the plugin option with our own QtProtobuf gen plugin. And we would also compile, link it, run it. And we see we're actually equal, or in the JSON case, we have a different ordering, but that doesn't really matter for JSON. What's important is the Protobuf output is the same, and that's what defines Protobuf. So you can, as I said, do all the things in the languages, but then when it comes to the binary level, it's all the same and also interchangeable. Since we're sane developers, we, as I mentioned, don't like to invoke Prodoc in the terminal for every project. So you see here how we use the QtProtobuf API with the QML option here. So we tell it, hey, we also want to generate a QML module for our generated messages that we defined in our Protobuf file. And otherwise it's a pretty basic CMake setup for a project. And let's look at some code. So on the left side, you see the C++ serializer, and on the right side, the QML code. And we first of all import our generated module, and can therefore also use our event message here as a property, and then use a change handlers and assign values to it. When it changes in QML, we will update our data, which should contain the serialized output. And yeah, simply call that function, serialize it, and that's it. But we could also write it like this, same code, just differently written, a bit more on the C++ side. So we have now our event here as a Q property and also the serialized output, the data, but otherwise it looks pretty similar. We also assign it, but then internally we do all the connections and serialize it. And if we would now add some nice layouts around it, I could show it to you. It would look like this. So it's all dynamic here. We could write things 25 and then change things here between JSON, Protobuf, and that's it. So let's move on to the really important questions of this talk, and that is to gRPC or not to gRPC. Let's find out if it's something for you. So gRPC adds something to the protocol buffers. With gRPC, you can now define services in protobuf files. As we see here, we have the event hub service, which contains 4 RPCs, and every RPC is of different kind. So the push is a unary call. The subscribe is a server stream. So we send a single message, get a stream of responses back. Or notify is a client stream. So we stream an amount of messages, get a single response back from the server. Or exchange is a bidirectional stream. So we can just exchange messages concurrently. We would also invoke prodoc on this, but with the gRPC C++ plugin. And we would get an interface for it. So gRPC generates stubs for clients with a stub interface, and then the service which you would need to implement to have a server. And there are different kinds of interfaces. So you have a synchronous interface or async callback interface. Or if you're brave enough, there's also an async interface with many parameters in those 3 dots, and you would need to manage everything by your own. And if you're just starting out, I would recommend you to start with the synchronous version and then move on to the async callback interface, since it already follows best practices. And the async interface is quite verbose and hard to manage. And I did this many times in my life, and to provide you a guide, I created this. So you start at A and you end at I, kind of like painting by numbers. And if you reached I and finally implemented the client successfully, hopefully, you would end up with such a structure, maybe. Or maybe your structure would look like this. Or maybe like this. I don't know. You decided. I guess you get the point. It's really easy to have multiple backends and languages communicate with each other in whatever language you have there. And those RPCs live inside a channel. A channel could be in HTTP2 a socket. And since gRPC is heavily based on HTTP2, it's not limited to it. There are also talks about like now HTTP3, but the core design was based on HTTP2, so those RPCs can also be multiplexed within the same channel. So you can have one socket open the whole time and then multiplex 1, 2, hundreds of RPCs in there. So let's look at some benchmarks again. Here we see the throughput in comparison to the payload size. And those 3 lines on the top represent the streaming RPCs. Of course, they're faster. We don't have to, we can just stream messages. And the line at the bottom is the one for unary calls. And we see that there is actually a sweet spot where we max out like between 1 and 2 megabytes per message payload per message size. And if we go further, we actually decrease again. So there's you would need to find a balance to find a way if you want to optimize for throughput or you would want to optimize for latency. So in the latency benchmark on the right, you see the blue line at the top is the unirecalled, and it's slower. And also note that the y-axis is in logarithmic scale. So there's also a sweet spot here. You see at like 32 kilobytes per message, we're like around 10 microseconds per message average latency. And then we increase linearly. So in logarithmic scale, it would be exponential. Yeah, but we only care about super high performance in the end. The only thing that matters. But we have to look also at more complex systems. Benchmarks often reflect a very narrow view on things. So let's see what companies and early adopters of gRPC have said. So Uber, for instance, one of the early adopters said it had a 45% increase in their connect latency in the 95 percentile. So 95% of the connect latencies were 45% faster. Dropbox didn't mention any numbers, but they said that they benefited from the standardization, the uniformity, the reduction in boilerplate code. Netflix mentioned also without numbers. Sadly, I hoped I would get more numbers from them. But they mentioned the incredible reduction in the 99 percentile that increased their developer productivity and reduced their code complexity. And last example, Spotify, also user of gRPC, mentioned the stability, performance, latency, the standardization, since before they used a custom in-house tool, as far as I know, and it's easier to integrate new people if it's just a commonly known thing. And yeah, they benefited from the ecosystem. They don't have to implement everything by their own, the load balancing, caching, and whatever networking options you have in there. You can just use it. So gRPC, of course, performance. We use Protobuf, binary encoding. It's small, it's compact, fast to transmit, low latency. We get the schema-driven API from Protobuf as well. We inherit it. And then the HTTP2 foundation just gives us nice things as we have multiple parallel streams. We can exchange data in real time. And also we have fine-grained networking options. So with the load balancing and caching, and there are many options to customize your stack. But the downsides, HTTP 1 and 2 are incompatible. That's a bummer. And we don't have browser support for HTTP 2 there yet. But there's actually a workaround, or not a workaround, a library to use there as well. So you could use the gRPC web proxy to simply translate HTTP 1 to HTTP 2. But it also adds some overhead. And, well, it also has some integration complexity, since we also use Prodoc and so on. And we have to learn a more or less complex framework. So even longer list of handshakes, I would say. We join a big ecosystem, and we can now communicate with all those other languages. So we also inherit all the good points from gRPC, also the bad points, but I don't have enough space on the slides here, sadly. So QtGRPC, at the C++ integration, we use signals and slots. I would say handling the asynchronous nature of RPCs with signals and slots comes quite natural. It's really nice to do it that way. Also, we use Qt networking and not some wild custom implementation. So things like your QSSL options can be used, things that you already know. And we use the Qt event loop to drive everything. The alternative, if you would like to use gRPC in your Qt application, would be to spin up a thread and pull it and integrate it then manually somehow into Qt. And not a very pleasant experience, and also not a very performant experience. Then we provide QML integration, so you can fire your RPCs only within QML without ever writing a single line of C++ if you wish. And also tooling. We also have a CMake API for Qt gRPC, and I would say we have great documentation and examples. We put a lot of work into that, like with the rest of Qt. And since Qt 6.8, we are a real module. Before we were in technical preview. And now we also provide stable, binary compatible APIs. And we did many performance improvements during that time, and we will continue to do so. So here we would also invoke product with our Qt gRPC gen plugin, which would output the interface that you would use. And currently we only provide client interfaces, so there is no server support yet, but it will come eventually. And on that interface, you would just call the methods as you wish: push, subscribe, notify, and would get a handler for it where you would interact with it. But I don't want to get into too much detail here. You can check out the good documentation that I already mentioned if you're keen to explore more. And it's only asynchronous, so we don't have a synchronous version of it. So let's compare Qt gRPC with gRPC. Qt version on the left, gRPC on the right. And we see actually so we have the 4 columns here, unary calls, and then the 3 streaming types. And we do quite well for small message sizes on the latency. We're actually a bit faster there, but then when the size increase, we suffer a bit more. And you can also see that in the QPS benchmarks, so how many queries per second we can achieve. And you can see we totally spin loose here in the client streaming case, 1.2 million queries that we can handle there. gRPC doesn't have that much of such a result there. But then our downside is we suffer a bit on the throughput, or not a bit, we suffer quite a lot there yet. But I will promise you, if you update your Qt version, we will fix it. You just have to update. So we max out there at roughly 3 gigabytes per second, and there's still more things that we can do. And I actually still have time, I think, for some live demo crazy. I tested it in the recent days, and I was always over my 30 minutes. So I actually have 2 live demo. I have another thing I want to show you, but first of all, I want to show you this. I'm really into audio production, and I was like, hey, using Qt in audio environments is quite tricky due to many technical reasons I don't want to get into now. But here we have a synthesizer built with Qt, the UI. And it's fully detached. So the audio engine does its thing, and then we notify our client, in this case the UI, through gRPC. So actually, I will terminate the process here and start the audio engine in the terminal. And you see here, we initialize a worker, and then the server is listening on a port, and we get an ID in this specific case, and this ID represents this plugin here. So we can play our stuff here. Some basic chords I added. Oh my god. Okay. But we could then also connect with a client. That could also be a mobile phone, for instance, or something like that. And we could say, hey, let me connect to that plugin. And we're connected, and we get our updates here of the notes playing. Whoops, gets a bit out of hand here. And yeah, we could even, if it lets me do it, send, for instance, something here, like a note on event. And yeah, I mean, you would need to create a interface for that. It would be quite unmusical to do it like this. But yeah, if that's kind of like what you could do with it, and I still have 5 minutes. Crazy. How is that possible? Okay, then I can even show you more content. Ah, no, wait, that's a video. What do I have MP4? Okay, here is the beautiful QtGRPC chat. One of our examples. It's quite an advanced example, and you can see how I can log myself in there, write messages, and yeah, I can even share files in there. I can actually share anything I want in there. In this case, I just used I opened the app 2 times, so it's on a different process and local host on the same machine, but I promise you it also works on my mobile phone. And yeah, we're sending here quite huge files, 120 megabyte files, and I'm talking to myself. And yeah, some more Hubble images, or 1 gigabyte zip files, or 3 gigabyte zip files. And it's nowhere to being optimized. I mean, the code there is quite rudimentary, but you get the point. Yeah, I would say that's it. Thank you. And